And your next question was, oh, the asteroid. Oh, you're worried about the asteroid. Oh, wimp. Well, there is an asteroid headed our way. By the way, I'm on YouTube describing this. And who here has not seen that YouTube video? Really? Okay. So I'll give you a version. This will be a live YouTube version of it, okay? Okay. Okay. So, December 2004. In fact, I may have to end on this question because I'm going to flesh it out in ways that there's no way another question can follow it. Okay. So, December 2004. Again, it's my community. I'm not out there. I'm occasionally out there, but most of the time when I say we, it's not me. It's just we, the astrophysicists. December 2004. We discover an asteroid. We have a couple of data points on its position in the sky. You look at its speed, you get a Doppler shift on it. You get its direction, you plug it into the computer. There was some 20% chance it was going to hit Earth on April 13th, 2036. Did you hear about this asteroid when it was discovered? No, because that same week was the Indonesian tsunami. That same week. And so rightly so, it did not lead the headlines the way the tsunami did. However, if you did the calculation, you would show that if it hit Earth in the center of the uncertainty range, it would hit the Pacific Ocean 500 kilometers west of Santa Monica. It would plunge into the ocean to a depth of 3 miles. It would explode at that depth, cavitating the ocean in a hole 3 miles wide. Now you have a wall of water 3 miles high. What happens to that wall of water? It just spills back into the hole that was just made, splashes into itself, and rises high again. That first impact creates a tsunami that's 5 stories tall. By the way, this asteroid is the size of the Rose Bowl. In other words, it would fit neatly in the Rose Bowl the way an egg does in an egg cup. So, So, here's the first wave. The first wave is just from that first impact. You cavitate the ocean, it fills up again, rises high into the stratosphere, falls back, cavitates the ocean again. Now it's water cavitating the ocean, not the asteroid. That sends another wave, and this repeats. Calculations show this will repeat about 40 times. 40 times. 40 tsunamis, one right after another. What's interesting to me is that tsunami would take out the entire west coast of the United States, do $10 trillion in damage. It would make the Indonesian tsunami look like a slightly overflooding puddle. So it was a lost opportunity to compare and contrast magnitudes of disaster. It would later make the news when better data became available. But let me explain this tsunami to you. So it's a wall of water 5 stories tall. The next tsunami, 40 seconds later, because it would be pulsed every 40 to 50 seconds, the next tsunami needs that water. There's not an unlimited supply of water. The first wave has got some of the water that the second tsunami wants to use. So what happens? The first tsunami goes in only as far. It goes 40 seconds into land. Then it's pulled, 20 seconds into land, 20 seconds back for the next tsunami. So in fact, if you do the calculation, you can show the tsunami would not go past about a 1/4 mile inland. You could set up a rope, like one of those club ropes, and just sit there and just watch the whole thing happen. The waves come in, they pass through the multi-million-dollar Malibu homes. The wave comes out, brings the home with it. Next wave comes, takes the home back in a slightly different shape than it was before. This process basically ablates the entire west coast of the United States. We would know this in advance, thanks to Isaac Newton and his 2 equations he developed as a 26-year-old virgin. And so, so actually nobody has to die. It'll still do the $10 trillion in damage, but we know this in advance. But I thought about it. There are two people who will die. Two people. And you know who they are. Okay? There's the idiot surfer who wants to get that last wave. You know, rad, man. I'm going to, the idiot surfer. We got one dead surfer and one dead weatherman. You know the weatherman trying to get the camera closer to the hurricane? Come, you look at the waves crashing on the shore, and the cameraman keeps backing up and he pulls him in. One dead weatherman. Two dead people, right? That's what you get. So a little later we would get better data. Once you discover an asteroid and you know its trajectory, you could look in historical photos for where it would have been in the past if you got your trajectory right. Then that becomes useful data to you. It's called a pre-discovery photo. It's common in my field. Once you have a general direction that something's going in, you just turn the clock back. Once we dug up pre-discovery photos and got some better data later, we were able to tune what was going to happen. So here's what will happen. On April 13th, in the year 2029, that's one orbit away from the 2036 date. It has a 7-year intersection orbit with Earth. On that date, April 13th, which, by the way, is a Friday. So April 13th, 2029, this asteroid named Apophis, named for the Egyptian god of death and darkness. Named, of course, only after we calculated its trajectory to intersect Earth. If it were not going to hit Earth, we could have named it like Bambi or Tiffany, something non-threatening, right? Freddy, something that it's not hurting anybody. Name that one Apophis. So we know for certain that Apophis on Friday the 13th, April 2029, it's the size of the Rose Bowl. It'll get close enough to Earth that it will dip below Earth's communication satellites. It'll be the biggest, closest thing ever known to come near Earth. The communication satellites are at geosynchronous orbit. It's about 23,000 miles up. This will come in at 18,000 miles. It'll be visible from northern Europe. The Geek Set has already rented the hotel rooms there, so you're out of luck, because they did the math and they knew when and where it was going to happen. It'll look like just a fast-moving, bright object across the night sky, moving at about, what speed do I give it? Probably around 10 miles per second. That's hauling. That's fast. So here's the catch. Its orbit remains sufficiently uncertain. Let me back up. In the possible range of orbits it could have on that fateful day, there is an interval range where if it threads that keyhole, we call it a keyhole. It's a 700 mile range. If its orbit goes through that range, Earth's gravity will be just right. Or rather, just wrong. All right? So that it will alter its orbit so that it will hit us 7 years later. So the test is it going to go through the keyhole? The latest estimates are that the likelihood, with updated data, is that the likelihood that it'll go through the keyhole is several in a million. Much better for us than the 30% first estimate or the 1 in 42,000 estimate that had been around for a couple of years. So you say, oh, not a problem. There are people who bet on the lottery with worse odds than that, expecting that they're going to win. Would you put $10 trillion in harm's way? Actually, if any insurance people here, I know there's got to be. You just do the math, right? $10 trillion divided by the probability of it hitting, spread that among the total population of the West Coast, and you have an insurance policy. That's how that works, right? That's how you calculate insurance policies. Oh, by the way, I think I saw Steve Soda here, my colleague. Steve Soda, we've collaborated on all the exhibits here in the Rose Center 10 years ago on our anniversary. Steve, could you remind me who of the famous astronomers of the past actually invented actuarial tables? Oh, Sir Edmund Halley invented the notion that you can calculate a risk using actuarial tables. An astronomer did this, okay? So it's good to have people who think about the universe. Who here only wanted to look at Earth? Where did she go? Where's my Earth woman? Did she leave? Yeah. Oh, she's still here? Oh, yeah, you're sneaking out over here on me. You're the one that only wanted to look at Earth. People who look up, like, also invent stuff. Just want you to know. Okay? So, the problem is so we don't know the orbit well enough to say whether or not it's going to go through the keyhole. We need better data on its location in space. So what we really want to do, and in fact one of the plans of NASA's next voyages, is to visit an asteroid. Why not visit the asteroid that has our name on it? The one that's headed this way. Just call Bruce Willis. You know, that's all you got to do. Put him on your speed dial, say, Bruce. No, we need Bruce Willis for the oil leak in the bottom of the thing right now. Then we'd send him into space. He was an oil rig driller, if you remember from Armageddon. That movie was made with a whole other universe of laws of physics, just so you know. Not from this universe. That's why no aliens made that movie. So where was I before I distracted myself? Visit, yeah. So here's what you do. You go to the asteroid, and then you stick LoJack on it, okay? Something where it's telling us where it is to like 1 centimeter per second accuracy, okay? And its velocity and its location with that accuracy. Then you put it back into the equations, you sharpen the orbit, you reduce the uncertainty, and you'll know whether it'll go through the keyhole or not. If it's targeted to go through the keyhole, all you have to do, well, if you're like military generals who know you got like nukes in the silo, you blow the sucker out of the sky. You know, we got those folks. We know who they are. The people want to blow stuff up. Problem here in America is that we're really good at blowing stuff up and less good at knowing where the pieces go afterwards. We're just less good at that, all right? So I don't want to blow up Apophis. Then we have 2 pieces, one headed for New York, one headed for LA. I don't want 2 pieces because we don't know what'll happen when you blow it up. So the kindler, gentler solution would be to nudge it out of harm's way. And all you have to do is nudge it so that it misses the keyhole. And that's only a 300-mile nudge, one way or another. And if you get it early enough, you give it a sideways motion. I'm headed towards you. Give me a sideways motion, a few centimeters per second, that accumulates so that after enough time, and I miss you completely. And in this case, you just have to miss the keyhole. 2029, that's the right amount of time in the future. Most of us will still be alive, we hope, and we can adjust budgets to make this happen. So all we have to do is engage international space agencies to do this. There are none. There is no organization to do this. And who's going to pay for it? We would surely pay for that, but suppose it was headed for the Indian Ocean. Doesn't affect America. It wouldn't affect us. So what kind of Earth insurance policy does the world take out? How do you work that? And we have an Apollo 9 astronaut, Rusty Schweickart, with a webpage called B612, dedicated to studying not only the physics of asteroid collisions, but the politics of how to alleviate them. B612, where have I seen that before? B612. That is the name of the asteroid that the Little Prince landed on. Oh, isn't that the cutest thing you ever heard? So that's B612. So people are thinking about it, and even some influential people. So if we don't mobilize in time, because we have too many lawyers among us and not engineers, like we can always get on the case of lawyers, right? Because I'm not alone. How many lawyers are here? Raise your hand. Oh, there's a lot. Yeah, there's a lot. Okay. But everybody makes fun of lawyers, right? In fact, my favorite lawyer joke was told to me by a lawyer. Can I tell you what that was? Can I tell you? He said, it's the 98% of all lawyers that give the other 2% a bad name. So I thought that was pretty funny. Lawyer told me that joke. That's pretty good. That's a pretty good joke. So here's what happens. If we don't mobilize in time, and it does thread the keyhole, we still have another 7 years. The problem is it's headed straight for Earth now. Now when you have to deflect it, you've got to deflect it by 4,000 miles by Earth's radius. That's a much harder job than deflecting it 300 miles, half of the keyhole. So I suggest that NASA go ahead and do this just as an exercise. Even though it's only a several in a million chance of it hitting, I want to know that we have the power to deflect asteroids so that we do not suffer the same fate as our reptilian ancestors 65 million years ago, who did not have engineers among them, so that as they're standing there dining on our mammal ancestors as hors d'oeuvres, I'm reminded of the Gary Larson comic. A T-Rex is talking to some other T-Rex, and they're just sitting there, just chilling, and one says, "Now is the time to build an asteroid defense system." Because I don't want to be the laughing stock of the galaxy, where others know that we were smart enough to have a space program, but too dumb to put it into effect and to save us from our own extinction.